Welcome to the AI in Manufacturing podcast here on Industry 4.0 TV. I'm your host, Kudzai Manditereza. And in this episode, we will provide you with the guidance on how to standardize your manufacturing data infrastructure with ISA95. And joining me in this episode is Jeroen Janssen, who is an ISA95 expert, MES MOM consultant, and currently working for Rhize Manufacturing Data Hub. Jeroen, thank you so much for taking the time to join me on the show. Welcome.
Thank you, and thanks for having me.
Yeah, so before we get started, can you introduce yourself to our audience, kind of like give us a background about yourself and tell us a bit more about Rhize?
Yeah, I definitely can do that. So my name is Jeroen Janssen. I'm an MOMS and MES consultant. Been in, I would say, manufacturing for more than 17 years now. Worked for quite a while at the system integrator, so saw a lot of different projects. Worked on a lot of different projects from PLC to SCADA to MES. I need to say that most of my experience is in the MES area. In the past, I worked as an engineer, so doing coding, then as a team lead, and later on as a consultant. And I can say almost every MES implementation that we did was always based on ISA95. That gives you a very good structure to build your application. But we will dive in that a bit more in a bit. And currently, for I think about 2 years already, I'm working at Rhize. Rhize is a manufacturing data hub, which you can also use as an MES platform or MOMS platform, I need to say, because it can do way more than just MES.
Yeah, I'm really looking forward to unpacking, more about ISA95 and Rhize Manufacturing Data Hub with you here today. So, 17 years in the manufacturing space, I'm sure you've kind of like really seen a whole lot of things that manufacturers are struggling with, particularly, this issue of data silos and integration headaches that's been, around for decades, I would say. So maybe as a way to set a context for our discussion here today, I would like for you to kind of like paint a picture for us on, what is the true, cost of that fragmentation that exists currently in manufacturing environments, and why would it be sort of like a time to change now?
Yeah, it's a very good question. Data silos is really a thing. I think it's something that really came from the past. You've got, if you look at manufacturing, there are so many different teams. You've got like operators, process engineers, but also management. They all have their own data set, what they've collected, mostly that grew over time. And they all look at maybe the same data or subsets of the data, but they all have a different source. So they're not all the same, or they're not all interconnected. In the years that I've been in manufacturing, you don't want to know how many Excel spreadsheets I've seen, and like very complex one that's been built over time, and there's a lot of knowledge in there. But still, everybody's like looking at their own piece of data, a historian or data from ERP, or there are so many points where you can collect data. Um, if you have so many points of data, for every person who has their own Excel sheet, that is the truth, right? That's what they are looking at.
Mm-hmm.
But is it? Is that correct? Or do they have a different source of that data? Or maybe it's not every little bit of detail is taken into consideration. Especially if you look at that reporting and different areas, you want them all to work together and have a single place where you can get that data. And especially with AI coming up, or not coming up, but it's there. You want to have one single place, and you want to have a single like multiple views on the same set of data. It's very important, like for us, but also for AI.
I'm sure you've probably seen this scenario play out quite a lot, where manufacturers get excited about AI or advanced analytics, and then they jump in, right, without having really sort of like solved these challenges that you spoke about. You sort of like your data living in Excel spreadsheets, you've got, fragmentation. But we have had, companies try some ways of, bringing their data, together, sort of like, as you said, sort of like try to create a source of truth, as it were. But it's surprising to me, because still I see a lot of debates, because we can't really agree on exactly what is the best approach of really sort of like creating that single source of truth. There's so many concepts that have come up, unified namespace, this and that. So maybe can you kind of like walk me through on what you see as one of the biggest things that manufacturers get wrong, sort of like in their approach to trying to sort of like create that single source of truth?
Yeah, so the same thing as we talked about before. If you have like different sources of data, but also different views of data, maybe different entities of data, people are looking at the same data, or almost the same data, in a different way. The same happens if you put AI on that. The first thing that needs to happen is we look at the same data, but we also have the same ontology. So you talk about, if you talk about an object or an entity, you know what it is, and what that means, and what context it has. I think that's very important to have that correct context, not just for the user to understand, okay, the data I'm looking at is within this time frame or within this order. And the same happens for AI. An example, if we and maybe you look at data and you say, between like this time frame or yesterday, we had a lot of metal detects. Right? I know everybody who's been in food manufacturing have seen that there's like a metal detector that says, okay, nothing enter my product. And if you look at the data and see, hey, there's a lot of metal detects, something was wrong. That's maybe a shift or an operator was not working correctly, or my machine was falling apart. But in the correct context, you can see that during those metal detects, there was actually maintenance happening on that line. And those metal detects were actually good, because there was a maintenance engineer put like a piece of metal through there to see if that metal detect works as it was expected. And for that reason, that context is very important. And to get full context of every angle of your manufacturing data, it's very important that all that context is in one place. So not just the context of ERP, the context of maintenance, or the context of your raw sensor data. If you have everything in the same place, people understand what's going on, but also AI can better understand what's going on there.
Yeah, I mean, that makes a lot of sense, and it also reminds me of there was a debate recently online, where we basically the thing was, how much should that context extend? Maybe, to use your example of saying, maybe a maintenance activity was going on, right? So maybe that's where that context starts, but maybe there's another piece of context to say someone put in the wrong lubricant in that piece of machine, right? And then kind of like that context extends. So my point here is to say, how far out should that, does ISA95 sort of like create those boundaries on exactly where does context start, where does it end? Kind of like, can you help us paint a picture of where does it end, or really, what is context? When we talk about context, what is it? Is it, some people, when they talk about context, they're talking about just putting a units of measurement on a data point. Some, to your point, are talking about, okay, what was the event that was happening during this specific moment, and then some talk about something else. So can you kind of like paint a picture for us, or not? What are the possible sort of like scenarios of contextualizing data?
Yeah, yeah, very good question. ISA95 has an activity model, and within that activity model, they describe like 8 very abstract activities where they say, okay, these are like the groups of things that can happen. And it starts very basic in resource management, where you say, okay, what are my resources? What is my equipment? What are my materials? What is my personnel? And also, what do we have? Just not just the definition, what is it, but also what do we have in stock? What is there? What can I use? Or what do I have on the shop floor? Which equipment? What equipment do I have? As soon as you describe that, define that, then you can build on top. You can build work masters, recipes. Do your definition management. How do I make something? And through that, you do like pre-production, say scheduling, dispatching, and then you move to the execution where you send commands down, like to the equipment. Can you start this? Can you execute this? During execution, you do data collection, and on top of that, you can do your analytics, your tracking and tracing, but also your performance analysis, like how is my what we actually did against what we thought that we're going to do. So your planned versus actual. What do you need to do that is you can look at case by case. So for some companies, you only want to look at maybe OEE, and then you can implement OEE and the data that you need. So for OEE, we need equipment, we need materials to see, okay, is one material running better to the against versus the other one, or is one line running better versus the other one? So you only get those items in. Next to that, ISA95 has a clear boundary between information that is coming from a level 4 system, so from ERP. Think about definitions on how to make something, but also a schedule, and also the feedback. This is what I made, this is how much I consumed, so you can update your inventory. That information is completely separate from the information that we send in between level 3 systems. So think about an MES system that interfaces with a WMS system, or a LIMS system, or CMMS system for all those tools. The same down, we have, or we in ISA95, there are different models that connect very good to ISA88, which is controls related. So there's like a seamless item in there, and even in ISA95, you see the same levels coming back from the Purdue level model, where you have that level 0 to level 4, where you have all that split, and that information is separate but integrated. So you can refer to each other, but you don't need to override it to get something. So data which you receive from ERP is owner of that data. And although we get it from like a read-only or informative information, if you want to build on top of that, there are other models that you link to your level 4 object, and then you can build on top of that without editing the source of the data. So within ISA95, there's so many objects that that help you structure that data and give the place that data. And then within that, you have different parts of your context. And so your context can be a job order, so an order which is running and what happened in that job. Or maybe you want to see what happened in that equipment, or why is this equipment different than the other equipment. So you have multiple anchor points throughout that complete activity model that you can use: a schedule, an order, a material lot. What happened with my material lot? Or why is this material lot as different correct specs than another one if you measure them from a QA perspective. So you have multiple anchor points which you can use as your context.
Yeah, I mean, that's super interesting. And it's kind of like, take a step back here, because I think you raise a good point really about, sort of like giving us a clear picture about especially the functional hierarchy model. You've got the different levels, level 0, level 4. And kind of like those are, terms that a lot of people, when they talk about ISA95, they mean, it's either functional hierarchy model where you've got that pyramid, or they're talking about the equipment hierarchy model where you've got like enterprise site area line. But there's just so much more to ISA95. So maybe to make that very clear for our audience, let's take a step back and kind of like break this apart and tell us which part of ISA95 is responsible for what specific standardization.
Yeah, that's so ISA95 has indeed multiple parts, many parts, and they all serve their own purpose. What I saw in the past is that a lot of people, they start reading part 1 and then go to part 2 and kind of got lost in all the entities and the naming and everything that is going on. I don't think that ISA95 has like a good like overview of this. This is what you need to go if you look for that. But typically, so it's strongly the part that you need strongly depends on what you're doing. So part 1 is like a very good introduction of the whole thing. So it explains what is my MOM domain, what is inside my MOM domain, so manufacturing, maintenance, inventory, and quality. So those are my 4 domains. Where does that sit in between ERP and in between your controls layer? How does that interact? So that's all like introduction written in part 1. Then if we jump to part 3 is the part where you have that activity model what we just talked about. Part 3 is very good to anchor your user requirements. So if you go look at the manufacturing, or you want to implement a new system or part of a system, part 3 nicely goes through all the activities that happen in manufacturing, and they go into detail where it is good if you read them through. You say, we do this over there, we use this over there, or we do this in this application or in that application, and that can be completely fine, but it helps a lot in like mapping the current state of your manufacturing automation, but also the future state. So you can see gaps and you think, okay, this is something where I need to improve. So that's what part 3 is very good for. Part 2 and 4 are kind of linked together. So those really go deep into your entities, your objects. So where do I store a schedule? Where do I store my results, my performance? What do I do during execution, and where does that information land within the ISA95 model? Both of them are very like UML and object oriented, so they are way more technical, those 2 documents, where part 2 focuses on the communication between level 4 and level 3, so information exchange between ERP and a MOM system, as well. Level 4 focuses on information exchanged between different level 3 systems. That is the difference between the two. Part 5 and 6, they are about not just what to send. So what to send is in 2 and 4. 5 and 6 is how to send it. So 5 tells you, okay, now we've defined this body and this set of information that we need to exchange. Then part 5 is, how do I put it in, like say an envelope, put a header context on it? How does transactions work? Or do I need transactions for the information? So that information is in part 5, and part 6 tells you, okay, I've got like two applications that need to communicate. How do I go from a local MES system that has its own implementation and set of database to like a global thing, and how do I send that? So how do I put it on the line? So part 5 also describes things like MQTT topics, or what would be channels, things like that.
Yeah, I mean, that's super interesting, because as you have sort of like brilliantly laid it out there, it's ISA95 fundamentally kind of like tries to cover all the scenarios within sort of like a manufacturing environment. And this is also a source of pushback that I hear a lot from the community, to say, by trying to to constrain, or to have this top-down approach of saying, this is how manufacturing works, this is how you need to sort of like operate, this is how you need to lay it. Some people say it's not realistic, because they want to have the flexibility to be able to change things around within the shop floor, and because of that, they say ISA95 is sort of like in a way scalable, right? Because it is kind of like trying to force this way of doing things, which is unrealistic. What would you say to concerns around ISA95 being too restrictive in that way?
Yeah, I had that question a couple of times myself as well, and that somebody asked me that. And I can even argue that I might say it's the other way around. It's harder to do it without. So let's dive a bit into why I make that statement. So let's say we talk about manufacturing. You're making something, so you release an order. That order is being scheduled on an equipment. We need personnel. We need an operator to run that line. You've got materials going in, materials or products coming out. And that works the same if you look at it from an abstract way. It's the same thing if you do maintenance. If you do maintenance, you also schedule, because you want to know that your line is down and you cannot use it for production. So you have access to that same equipment, that same line, and then you schedule it as well. You also consume or use materials, parts in this case, that maintenance can use. You also need personnel, somebody who can do that. And the same happens if you look for all the other activities. For people who have looked at ISA95, it has so many different entities, and I think that is because you've got so many different views and different ways of like collecting data. That's also why the standard is still evolving. I think the 10th of April, a new version for part 1 came out, and we're waiting for a new version of part 2 as well. That's coming soon. So basically, we have, I think the first release was in 2020, in 2000. So we have 25 years of experience into the ISA95 standard. In the past, I ran into issues as well, that I thought, this is like a very edge case, something unique that doesn't fit into the standard. how can we solve this? Do I need to extend the schema? And then if you talk with other colleagues and other experts, it turns out that yes, there is like a model, or yes, there is something where you can add it in and it makes sense. It's just that I never used that entity. So most of the time, if it doesn't fit, it needs more investigation, because at the end it turned out that like 99% of the cases they work. And the reason why I say it's hard to do without, so ISA95 describes an ontology. It describes, okay, these are my entities that you can use. You can fill them in. You can fill them in now, or you can do that later. But that means if you have that entity, that ontology, you know what it means. You know the context, or you know what is a material lot. So there's a very good description of what is a material lot. So everybody who is trained in ISA95 and who's looking at that data knows what it is. And then if you scale and you grow, you get more people looking at that same data, and more items coming in, but everything already has a placeholder. So it's not that I built my own structure and now I've got this new use case and something came up, so I need to add a column in my table. No, there is a placeholder, so you just fill it in. You left it empty all the time, and now you just fill it in. Also, I think that ISA95 describes that ontology, but it doesn't describe how to use it. So it doesn't say you need to use XML. Back in the day, we used an XML file that we put on a file share and then picked it up. That's not from today. Today we use JSON on MQTT. So the implementation changed a lot, but where to store it and that ontology, I think that's a very good place, because everybody talks about the same thing and have that in the same place. And especially with new technologies that we have currently, think about, I already mentioned JSON, MQTT, but with new things also like scalability on Kubernetes, and it is very easy to put a lot of data in a single place, and your performance is still good. So you don't have any issues there. And also know that ISA95 is multi-site from its core. And there are special tools like hierarchy scope to map data to a certain site, but you can still have access to all the data and compare even sites instead of lines. So to circle back, without that ontology and without having a placeholder for all your data, even if you don't need it at day one, is very important for scalability.
Yeah. So, I mean, I think you mentioned the fact that so ISA95 is an ontology that doesn't detect, how you should implement. So it could be XML, JSON. So I wanted to sort of like touch on two implementations of ISA95. You have something to share with regards to that?
Yeah. So B2MML and BatchML, those are implementations of ISA95. B2ML is a standard. It's started as an XML standard, and what it basically does, it gives you the XML schema, so XSD files, which you can download for free, and you can use that, and that is an implementation of ISA95. It's not ISA95; it's an implementation of ISA95. I say that because at some places, B2MML has a slight different implementation than the standard describes. It's not an issue because you can extend that schema, and you can that gives some flexibility. B2MML also has a JSON schema that they provide. Be careful with that, because the JSON schema is generated from the XML, and it has a few things that doesn't work as well as they do in the XSD files, but still you can use it, but you cannot extend it, for example. Does that answer your question?
Yeah, absolutely, absolutely. Yeah, so I mean, I've looked at some parts of ISA95 myself, and they can feel pretty overwhelming. Just looking at the the corpus of information there. So for a manufacturer who's maybe convinced that ISA95 is the right path, how should they begin to approach implementation, and maybe more importantly, how should they how much do they need to model for them to start to see some real value?
Yeah. Yeah, I fully agree. When the first time I read ISA95 years ago, it was very overwhelming. I took a few trainings, a few courses myself, and slowly get more and more in it. And you start with the basic things that everybody needs, so material, equipment, and a job order, and stuff like that. And then slowly expand on things that are not that common. I think that the most important one is to get your use case clear. So what do you want to do? What do you want to achieve with that? Do you want to get less downtime, or maybe get insights on your downtime? Do you want to improve scheduling so we have less changeovers? What is it that you want to do? Or maybe you need tracking and tracing of your lots and see what happens there. The most important part is there. So you look at, okay, I need to get this report, and then to get that data, that means that I need to collect this upfront, and that's always where it starts. So to be able to do good analysis, you need to have the correct data in a good quality. That is the most important part. So then work your way back. What I mean is, if we in that activity model, what we talked about before, at the end is analysis, for example. So if you want to look at that, you need to say, okay, what data is important for that? Is my schedule important? Yes, then bring it in. Is my actual start and end time important? Yes, then try to capture that from controls. Is my material important in that? Yes, bring it in. Your equipment? Yes, bring it in. Is my personnel important for that? No, for this use case, not. So leave it out. Even if you have it available, just leave it out. And go step by step. Look at what is your use case. Just bring in that data, and then get that use case up and running, and then go to the next use case. The term that we often use is use case stacking, where we say, okay, the first use case that we look at, we need to model a lot, because you need equipment, you need materials, you need all the items to get to that first use case. But maybe for your second use case, or your second report, or your second screen, you need maybe the same amount of data, but you already implemented maybe half of them. So that means in the beginning, it's the same amount of effort, but because you already have done that, and it's in the same place, and we have that one single place where all that data is in that correct ontology, it's only adding in additional information to come to a new result. And the next use case you implement is even less effort, because you have more items in place and more entities already filled in. That happens not just on manufacturing, but even if you bring in other domains, like maintenance. If you bring in maintenance, maybe your schedule starts to make more sense, because why did I have gaps in my production schedule? And now you can see, okay, that filled in due to maintenance schedules. bring in inventory. Why was my my line waiting for a certain amount of time? Well, I think I had everything ready, and as soon as you bring in quality information in, it turns out that we were waiting for a sample to be analyzed, and that's why you have that gap in your production. So the more data you bring in that place, the more you have. But start small. That's the key thing. Start small and just build up, and we can do that because all the placeholders are already there.
Yeah, so now let's talk about Rhize Manufacturing Data Hub. So yeah, I mean, let's maybe start by just give us a brief breakdown of what exactly is Rhize Manufacturing Data Hub, and then from there tie it into how it implements the ISA95 standard.
Yeah, sure. So Rhize Manufacturing Data Hub is, I think at its core, completely different from any other MES system that I've seen. And it's different on a few key aspects, where we talked about ISA95 is at the core is an interface standard. And what most of the MES systems do is they have their own data set, they have their own tables, their own structure inside. And if they say they are ISA95 compatible, they are ISA95 compatible at the edge. So that means that they have an API that talks ISA95, and they do like an internal transformation to say, okay, if I want to send this ISA95 object, I need to pull data from these tables and then send that out. Where Rhize differs is that Rhize stores the information as ISA95 objects. So every ISA95 entity that we have in the standard is also in the database. So that means that, one, we never need to do that transformation. It's we have ISA95 all the way through it. And also, if you want to query that data, so if you want to pull out that data directly from the database, it is already ISA95. So we don't need to change anything. It's very fast, and people can pull out that data and stay in that ontology, have that all placed. Another thing where Rhize is different is that Rhize is rigid at the core. So our database schema is rigid. It's you can make changes, but think about everything is ISA95. So if you put data into ISA95, you don't have to change it. You don't have to extend it. So think about, you never need to. There's no need to change the database. And then the outer layer, so think about it as an onion, like the core ISA95 database, very rigid. And the further that we move outside, so on top of that database, we have like a structure, an API where we pull out data or do like low level logic. And then we have an outer skin where we can do business logic and where we can place a UI. And there we have low-code tools to build customer-specific information. So although if we look at manufacturing from an abstract way, it's almost always the same. But if you dive in deeper, yes, there are differences between factory 1 and factory 2 and customer 1, customer 2. And that's why we have that flexibility. So the implementation, so getting data in, getting data out, or maybe doing some business logic that we do on an event or something, that is very, with low code, you can implement that. If it's too complex, you can even build a microservice. But to ingest that data and understand that data, it's very flexible. So out of the top, we have like standard functionalities, but very basic. We don't have like a standard order execution screen or a flow that we need to follow. No, we can very easily customize that to the customer. Same for the UI. We use low code, no code tooling on top, so we can change the UI to the customer's needs. If they don't use a field, we don't show it. If they already have a UI where the operators are trained and they say, we want to, our system, we need to replace that because it's getting too old, it's not supported anymore, but we don't want to train all the operators again, we simply put the same screen on top but with new logic behind it. That complete setup with having a rigid ontology in the middle and being flexible on the outside, so flexible to interact with other systems and flexible also to interact with the user. That flexibility also allows Rhize Manufacturing Data Hub to be just that, a data hub. So it collects all the data. It's a single point where you have all the data, where you can do very fast reporting on. But you can also add screens to that. So say, okay, I want to add MES functionality or maybe WMS functionality on there. Or maybe do like a hybrid to say, okay, I've got these factories or multiple sites that all put data in there, but I've got this site where we don't have MES. So you add MES on top of that, add a layer on top of your Rhize Manufacturing Data Hub, and it acts as an MES system.
Awesome. Yeah. So I mean, I know that underlying your platform is a graph database. I think I would imagine this is kind of like where all these entities and their relationships that you create for with respect to ISA95, they live there. So maybe can you sort of like help us, understand the logic behind adopting a graph database for this implementation?
Yeah, definitely. I have a heavy SQL background, and started working with graph like 2 years ago when I joined Rhize. And I see, like, if we look at ISA95, it is a huge set of entities and relationships between the two. So sometimes if you need to get a set of data, it's like spread over multiple tables, entities. So if we looked at SQL, then if you want to get all the data together, you get join after join after join. So you need to write like 2 pages of SQL code just because you want to start at an anchor point, your ontology, what happened during this job, and then go to multiple entities described in ISA95 to get maybe equipment values or process values, because they're quite nested. Graph has a different view. Instead of like having all those joins, you can simply query an entity, and if you hit a dot, you get your attributes, but also your next entities. And you can just click or select that next entity, and with all these dots, you can just like drill down and get that data in, and in one data set, you get it out. So you don't need a lot of joins, and especially if we look at that ontology, like, okay, give me the information of this equipment versus that equipment. That query is very simple. It's very simple due to the way that graph is structured. And another very nice thing that we did within Rhize is that we use 2 databases. We have a graph database and a time series database. Graph is for all your event-based information, and your time series is just like raw sensor data that you can pull in. But what our that additional layer that we built on top of that graph database can do, allows us to do, is simply go to maybe to your equipment. So get your equipment, then navigate to your properties of that equipment, and then just say dot value, and you get the set of values within that time frame. So let's say you start it at a job order, which has a start and an end time, and then go to the equipment that is used, and then go to his properties, his values, and then say, okay, give me the average temperature. And it's directly there without joins, and it combines two databases, and you get that information there. So pulling data is very fast and very simple to do, next to all the benefits of performance.
And maybe before, so I also want to talk to you about, how you typically engage, customers, how you sort of like, approach the implementation of Rhize, Manufacturing Data Hub. But just, before we go into that, can you speak just briefly around the business benefits, or more specifically for, companies that are, implementing AI or data analytics? Why is Rhize a suitable platform for building sort of like a data-driven organization?
A few things. First of all, performance, and not just we just talked about how easy can we get data out of the platform in the correct context, because you start with that context. So it's very easy to learn a graph and get that information out, but also performance. As data grows, and you've got one side, you add another side. Indeed, we typically start with a proof of concept, then go into a pilot, and then we can either say, okay, we're going to scale in functionality, so add more functionality in using that use case stacking, or we're going to scale and add more lines in, or maybe more sites in. But you get more and more data, and since we are running in Kubernetes, it's a containerized environment. So if we have a lot of payload, that environment automatically scales up. It adds another container if there's a lot of load. The other benefit is that if we have a new release and it passes through your testing, your validation, and we need to do the rollout in production, we can push that new version. And with Kubernetes, we don't have downtime because it scales up new containers and then it spins down the other ones. Rhize can either run on-prem, or you can put it in the cloud with the current environment, and also with the good security rules in place. It is very easy to put Rhize in the cloud and have that data streamed up. So you have a small instance per site that is collecting the data, buffering data if needed, and then it pushes it to the cloud. And that makes it very easy if you have it in a centralized environment to compare different sites. We can also do that on-prem and have multiple sites. So that's the flexibility that we have. But I think if we have that, so proof of concept, pilot, and then we have multiple ways to scale it on a functional level, but also on a technical level to get performance, keep performance good, have that flexibility, and have it very accessible for users to have to pull out the data for AI, and because AI, just like us, needs that context as well to understand, okay, this is what happened and this is why it happened. Does that answer your question?
Oh yeah, absolutely. Maybe if we've got some examples of actual ISA-95 implementations you've been a part of that you could share with us, and maybe sort of like talking to us about what are the challenges that the companies were facing, and kind of like how you went about implementing that.
Yeah, one of the projects where I was involved, they are very strict on what happens during production. So they had an electronic batch record. For those who don't know what it is, it's a report that basically tells you everything that happens on that batch. So every batch that is produced has a unique serial number, and with there you can see everything from which ingredients came in, where did the ingredients came from, with what settings did my machine run, what are the actual values, which operators worked, who signed off, like the whole thing. That electronic batch record was like 300 pages long, so it's a lot of information. And that information was stored in different silos, and when you run the query, like that data is pulled together from different locations. Most of it were like SQL queries, which we just talked about, having so many joins to get all the data together. That a single report took them like 20 minutes to run. What we did there is we installed Rhize as a manufacturing data hub. We put it in place, and the only thing that we did is listen to the mostly the channels which are already there. So if there was a data exchange taking place, then we listened in on that. So we tapped in on that information, and we stored that in the manufacturing data hub. We did that with a lot of like systems to get everything together. And of course, there were some gaps in the data that we actually needed to pull the information, or we got an event that, hey, it's done, and then we could pull that information. And what we then did is we made a copy of that report, but then pointed that copy towards the Rhize Manufacturing Data Hub. And from that 20 minutes where they did to run that report, we went into milliseconds time. So you clicked it, it's open. So that's a good example where we used it as a data hub. Maybe another example. We have a client where we started as a proof of concept. We did a pilot. We did that use case, and we have that ready. And they decided to continue with that. But they really like the approach to make it like part as their application lifecycle management, to say, okay, we have this issue in manufacturing. How can we add that into our application? So they by themselves trained people into using Rhize and to use ISA95. We did their first POC pilot, maybe helped. We were a bit more involved with like the next use case, but slowly they took over the implementation, and currently we are like in their continuous improvement cycle, where they say, hey, we've seen that we have something is happening here, but we don't know what. And then their own team picks it up, writes the requirements, does the implementation, maps it into ISA95, obviously, does the implementation and testing and do rollout. And we are currently not heavily involved. We only like guide if they have like very hard questions or something like, hey, how do we model this? Then we have a consultant that's there that helps and that maybe verifies if it's all good. But they are by themselves like evolving and growing that functionality, which I think is awesome if the customer can do that by themselves, but having that low code, no code top end where they can edit and get their own business logic in. Yeah, I think that's awesome if customers can do that.
Oh yeah, absolutely. It really sounds fascinating. So Jeroen, unfortunately, we've run out of time, but we are certainly going to provide links to in the description of this video and all the podcast platforms for where people can find you and how they can contact you if they need to find out more information about ISA95 or how to engage you as far as Rhize is concerned. So, thank you so much for taking the time to join me on this show today. Really appreciate it.
Thanks for having me, Kudzai. It was a pleasure.